All right, let's talk about linear approximation and differentials. All right, so with linear approximation, we're just going to kind of scratch the surface of this. And it's literally exactly what it says. A linear approximation is going to be this formula. Capital L of x is equal to f of a plus f prime of a times x minus a. Now tell me what that looks like. It's written a little differently, right? What if I rewrite it like this? L of x is equal, oops, lies. L of x minus f of a is equal to f prime of a times x minus a. Does that look more familiar? Kind of. What's this f prime of a? What is a derivative equal to? The slope of the tangent line, right? So that's talking about a slope. What if I write this as y minus y1 is equal to m times x minus x1? Linear approximation. This formula up here, it's just point slope form. Whenever we've been finding equations of tangent lines and all that kind of stuff, we find our derivative first, right? Then we just put it into point slope form. The biggest deal here is I have the y, or this L of x, and all you've done is just added this f of a. Oops, I put f of x there. That's my bad. I add this f of a over there to that other side, that y value. It's just a point, right? I've got a and f of a. That's my point. A, f of a. So if I'm looking at this point slope form, I have the point of a, f of a, and I have the slope here of f prime of a. That's it. Not bad. Okay, so let's do one of these. Here's example 2a. Let's scoot this up a little bit here. It says, find the linear approximation, and learn how to spell here, to the function f of x is equal to the square root of x at x is equal to 1. All right, then we are going to use it to approximate the square root of 1.1. All right, so we want to find the linear approximation formula here to our function, the square root of x. Now here's where linear approximation actually happens. A lot of times you have some algebraic equation. In this instance, it's the square root of x, or something even crazier. We're just hitting the highlights here, learning our basics. You could have something even crazier as you go forward, but this is just practicing to get the process. And then something that is linear is the easiest possible way to find a value. So L of x is equal to f of a plus f prime of a times x minus a. So in order to pull any of this off, we need to have a slope. We need to have a point. Those kind of ran together, didn't they? Let's try that again. Minus an a. So I know that here's my x, but to get that point, I have to have f of 1. So if I take the square root of 1, that is 1. So there's my coordinate point, 1, 1. And I also have to have a derivative, right? So if I'm going to look at my derivative, I should put this over here. Hang on. Well, no, I've got a point. That's fine. We'll just put my derivative right here. So I've got f prime, that's right, f of x is equal to x to the 1/2. F prime of x is a 1/2 x to the negative 1/2. But I specifically want my slope at that value, right? I'm going to rewrite this so that it looks a little bit nicer. So 1 over 2 square roots of x. So f prime of 1 is 1 over 2 times the square root of 1. So my derivative at 1 is 1/2. That's my slope. Then I plug it all in. So L of x is equal to 1 plus this 1/2 x minus 1. So clean that up. L of x is equal to 1 plus this 1/2 x minus 1/2. And I'm going to write my slope up front just because it's nicer to look at slope-intercept form that way. Right? Okay. So you have L of x is equal to 1/2 times x plus 1. Now here's the deal whenever you find your linear approximation. If there's something you can do to simplify this or to break it down, we're going to want to do that. So I'm going to factor out a 1/2 because with this linear approximation, if I want to approximate, which is the second part, this square root of 1.1, what we're saying is this is my input value. So everywhere I see an x, I'm going to input that 1.1 because my function is the square root of x. So the x that we're actually trying to find is 1.1. So this L of 1.1 is going to be 1/2 and 1.1 plus 1. See that? So now it's much easier to plug that 1.1 in when you have that 1/2 factored out. Yeah, and a lot of times it is whenever you have to go plug in something that's a little crazier. So L of 1.1 is equal to 1/2 times a 2.1. I don't know. What is 2.1 divided by 2? 2.1 divided by 2. So 2 goes into 2 one time. You bring the 0 up. And then goes in there 0 times. Would you put a 0? 2 goes into 10 5 times. So 1.05. So this would be 1.05 that we're looking at. All right. So we're saying that 1.1 here is approximately 1.05. Well, let's get out our handy dandy calculator and check it just so that we can see this is supposed to be approximating, right? That's the whole purpose. We did all of this stuff without a calculator. We came up with an approximation of the square root of x. We wanted to figure out what the square root of 1.1 is. Well, we don't have a calculator in front of us right now, right? But we wanted to do that. So let's check. Check on a calculator. Do that. What do you get? Yeah, 1.0488, so on and so forth, right? That is very close. Nice. It's very close. So our answer here of 1.05, this is just saying you can use a linear approximation, right? You can find something that is a linear approximation, and then you can check that out. It's just another way. So what is chapter 4 about? Using the application of a derivative. So a linear approximation is that application. Now, in reality, if you wanted to find the square root of 1.1, you're just going to plug it in. But sometimes as you're working different problems, a linear approximation is helpful as you're getting into these bigger problems. All right. You're not necessarily going to do that to find 1.1, but you never know where you're looking at these problems. Again, tools in the toolbox. Tools in the toolbox. Linear approximation is just point slope form. All right, cool.